Hi everyone, we are Group 5 of DSI Section K32, consisting of Cabalde, Villado, Nang, Ocampo, Rubio, and Sangalang. For this video presentation, we'll be presenting Chapter 6, and under that, Case 6.2. So this case focuses on Communicorp, a company struggling with poor internal communication between departments. So even though their productivity has gone up, they've been losing customers because of missed or late orders. The core issue here, departments like sales, manufacturing, and marketing weren't properly coordinating, which led to the routers being produced randomly and stored without regard for actual customer orders. To fix this, the company plans to implement an internal intranet system over 5 months, rolling it out department by department. Our job is to create a cost minimizing plan to purchase servers that support this internet rollout. Each server type has a different capacity and cost, and discounts are offered if servers are bought early. There's also a $9,500 budget cap for the first 2 months. So overall, this case is about finding the most efficient way to buy servers based on cost, timing, and capacity needs per month.
The information needed to solve this problem are as follows. For a mini desktop, 30 users is equal to $2,500. For a desktop server, 80 users equals to $5,000. And for a workstation, 200 users equals to $10,000. And finally, for a full rack, 2,000 users equals to $25,000. A spreadsheet model was formed to help Emily determine which servers Emily should purchase in that month to minimize costs and support the new users given. She also wants to figure out how many and which types of servers she should purchase in a month, as well as the total cost of the plan. We use the built-in solver in the Excel to minimize the total server cost for each month while meeting the required number of users. The objective cell, G22, calculates total monthly cost. Our decision variables are the quantities of each server type, located in cells C16 to F20. We added constraints to ensure all server quantities are integers and non-negative, that the budget in months 1 and 2 doesn't exceed $9,500, and that the total capacity meets or exceeds the number of employees each month.
As for the formulas found within the sheet cells, we first calculated the potential discounts to be availed in months 1 to 2 for the workstation server, the 10% discount, and the full rack server for the 25% discount. For the first 2 months' discounts for the workstation and full rack server, we calculated this by inputting the formula normal cost minus the sum of multiplying the normal costs by the specified discount. Shown here is an example of the formula used in these cells. The mini and desktop servers get no discount. Next, to get the potential costs of each month, we utilize the sum product feature to multiply the cost of server by the number of servers purchased as decided by the decision cells, which the solver will utilize. We did this for every row or month, and the final total cost cell is the sum of all these monthly costs. Then we calculated the available capacity from purchasing each server as to be decided by the solver. We did this by multiplying the number of employees each server supports by the number of each server purchased for every month. We made sure that it was greater than or equal to the number of employees that needed these servers per month. Lastly, we had to ensure that we followed the given constraints. For the budget, we simply added the total cost of months 1 to 2 to ensure we stayed within the budget of $9,500. And we made sure that month 3, or the month for the manufacturing department, had more than or equal to one of the 3 most powerful servers.
Now, to first solve the problem, we used Excel Solver to minimize the total cost across the months. First, we selected the objective cell. This is the total of all monthly costs, and then set it to min. Then we set the changing cells to the yellow boxes that represent the number of servers per type per month. These are our decision variables. Next, we added constraints. Firstly, all values must be integers because we cannot purchase mere fractions of the servers. Total cost for month 1 plus 2 is less than or equal to $9,500 because of the stated budget. Manufacturing month or month 3 must have at least one desktop, workstation, or rack server, as stated in the problem. Capacity for each month will be greater or equal to employees needed, so that all employees for the month are accommodated. We used the simplex LP solving method, and after hitting solve, it gave us the most cost-efficient server plan based on the monthly requirements. In conclusion, Emily needs to purchase nothing in month 1, one desktop server in month 2, one workstation server in month 3, one mini desktop server in month 4, and one desktop server in month 5. This will lead to a total minimized cost of $22,500.
To solve problem B, we created a spreadsheet model to help Emily decide how many and which types of servers to buy over 5 months to minimize total cost while meeting employee needs. The given data includes employee rollout per department, 60 employees in month 2, 200 in month 3, 30 in month 4, and 75 in month 5, as well as the server capacities and prices. Mini desktops cost $2,500 with a capacity of 30, desktops cost $5,000 with a capacity of 80, workstations are $9,000 in months 1 to 2, and $10,000 after with a capacity of 200. And full racks are $18,750 in months 1 to 2, and $25,000 after with a capacity of 2,000. The objective is to minimize the total cost while ensuring each month's total server capacity meets or exceeds the number of employees. 4 main constraints were included in the model. Server capacity per month must meet the required employee support. The total server spending for months 1 to 2 must not exceed $9,500. At least one workstation or full rack must be purchased in month 3, and the number of servers must be in whole numbers. So in the spreadsheet, we organized the data into sections for inputs, decision variables, and formulas to calculate total costs and monthly capacities. We used Excel Solver tool, setting the objective cell to minimize total cost, identifying the variable cells, applying the constraints, and selecting the simplex LP solving method with non-negative values. After running Solver, the results showed that the most cost-efficient plan had a total cost of $19,000 with one workstation purchased in both month 1 and month 3, meeting all constraints while supporting employee needs across all departments.
First, for the objective cell, the formula is sum F15 to F19, which is the sum of the cost for the servers. Next, for the constraints, the formula for budget is F15 plus F16, which is the sum of the cost for the first 2 months to ensure the budget remains below $9,500 within the first 2 months. Next, for the constraint capacity, the formula is sum product B15 to E15 and B9 to E9, plus the excess capacity in the previous line, to account for the excess capacity from the previous servers purchased. Lastly, the formula to obtain the cost is sum product B12 to E12, comma, B15 to E15, which for the first 2 months is multiplied to discounted cost to apply the discount, while for the months 3 and beyond, it is applied to the cost of the server.
Moving on to the explanation of the constraints and other information in the parameter dialog box, we can see that there is the objective cell, which is the F21. It is also the total cost, the 2, or min, which is the minimizing cost, and by changing variable cells, which is the B15 to E19, these represents the number of servers per type per month and are also the decision variables. There are 3 subject to the constraints. The first one is the decision cells, B15 to E19 equals integer, or the changing variable cells equals integer. This means that it cannot purchase mere fractions of the servers, or that the value should be a whole number, no decimal, no fractions. Second is the budget for months 1 to 2. B22 is less than or equal to D22, or total spending for months 1 to 2 is to be less than or equal to the budget limit for the first 2 months. B22 consists of F15 plus F16, which is $9,000 plus $0, and it must be less than or equal to $9,500, which is the budget. And lastly, the server capacity G15 to G19 is greater than or equal to I15 to I19, meaning that the capacity greater than or equal to the employees needed to ensure sufficient capacity, meaning that all employees for the month should be accommodated. Moving on to the results from months 1 to 5, we can see that month 1 has a purchase of 1 workstation server. Since it was within the discount windows of months 1 and 2, the discounted price of 10%, which is $1,000, applies. Therefore, it is $9,000 instead of the normal cost, which is $10,000. For month 2, there are no purchases. And then for month 3, another 1 workstation server was bought, but this is outside of the discount window, which is during month 1 and 2, so the full price of $10,000 was paid. And then there are no purchases for months 4 to 5. So if you look at the total cost, there is $9,000 for month 1, 0 for month 2, $10,000 for month 3, and 0 for months 4 and 5. So $9,000 plus $10,000 equals to a minimized total cost of $19,000. Moving on to the conclusion, overall the total cost was minimized to $19,000 by leveraging discounted prices available in the first 2 months. Unlike problem A, which approached the decision month by month, problem B evaluated all 5 months as a single planning horizon, offering a broader, more strategic view of the demand and purchase timeline. This allowed Emily to optimize bulk purchasing during the discounted window, avoid unnecessary repeated purchases, and minimize redundancy across the months from 1 to 5. By focusing on high-capacity servers like workstations, she reduced the number of units needed without sacrificing performance. In essence, problem B highlights a holistic, cost-efficient, and capacity-aware approach. By front-loading purchases and making strategic server selections, Emily cut total cost by $3,500 without compromising capacity needs.
So why is the answer using the first method different from that of using the second method? This is because problem A solves each month individually. It can only look at the month's requirements and costs, which means it can miss out on better long-term savings. Problem B, however, treats the entire 5-month rollout as one big problem. So instead of waiting to buy servers month by month, it might buy a large server early to cover multiple months, especially since some servers are cheaper in months 1 to 2 due to the discounts. That's why part B usually ends up cheaper overall, because it takes advantage of bulk purchases and early discounts, something that month-by-month model in part A doesn't fully optimize.
Emily's current formulation considers purchase cost minimization and capacity fulfillment, but she only accounts for the initial purchase costs of servers and whether their combined capacity meets the monthly employee demand. Instead of oversimplifying the total costs of implementing a company-wide intranet system, she could consider first maintenance costs. Servers may require maintenance over the months, and Emily's idea to purchase servers early implies that they will be in use longer, increasing the possibility of wear and tear. There may need to be a budget allocated for this. Next, we have installation costs. The server needs to be installed, configured, and connected to the company systems. Multiple purchases across months will increase setup labor, so time and budget need to be considered for this. And we also have logistical costs. Some servers may require specialization in allocated space and support. It's mentioned that the full rack servers, the 2000 capacity one, are high density machines that may not be installed in standard office spaces, so this may be a constraint to consider.
Additionally, operations costs and software licensing fees are other costs which Emily is not accounting in her problem formulation. Operations costs. Larger servers consume more power. Therefore, Emily's plan to purchase high-capacity servers early on would increase monthly utility costs. There may be electricity budget concerns to add to the constraints. And lastly, software and licensing fees. Servers require operating systems and data management platforms. These are often paid for, and the more servers deployed, the more licenses needed. In theory, the current model would present a scenario that works. However, it lacks realistic costs if it were to be implemented.
With the introduction of centralized intranet system, Communicorp stands to have its own concerns regarding its various departments regarding the intranet. The financial and structural benefits are clear, while employees from various departments will likely hold different expectations towards its adoption. Having insights on the possible concerns will help foster smooth transitions during intranet implementation and increase participation among employees. The manufacturing department heavily relies on scheduling, inventory data, and production orders. A few concerns it may have would be if the intranet would cause delays in receiving critical production updates, or at the worst case scenario if there's downtime mid-production. Another is the warehouse department. As the team needs up-to-date inventory tracking, would the system lag or sync issues create any shipment errors or delays? The warehouse department may also worry if the interface is overall user-friendly for warehouse tasks that may only have limited text skills.
So the third one is sales team rely on secure and fast access to client data and order systems. Without it, they may miss important opportunities. For marketing, a lack of real-time collaboration or proper version control can lead to inaccurate materials that harm the brand. And number 4, poor security measures could expose sensitive data like financial records or customer information, which could result in legal issues and damage the company's reputation. So in short, Communicorp must involve all departments, implement strong security, and provide a reliable intranet that supports smooth operations across the company.
That's all for our presentation. Thank you so much for listening.